In this video, we're going to find the inverse of f of x equals 2x over 2 minus x. So in this video, separate from the other ones that we've looked at, we have two different places where x occurs in our function. So we're still going to follow the same four steps. You always follow these steps seen on the right-hand side in green when you're looking for the inverse of a function, but we're going to have to do a little bit of extra algebra in the middle, as you'll see. So let's go ahead and apply our first step. We want to replace f of x with y. So we're going to rewrite this problem as y is equal to 2x over 2 minus x. And then our second step is to change all of the x's to y's and all of the y's to x's. So here's the first divergence from problems we've seen before. We're going to rewrite this as x is equal to 2y over 2 minus y. So now we have two different places where y happens. And that comes into play now that our third step is to resolve for y. So the first thing we're going to have to do is we're going to have to get this y out of the denominator. And so to do that, we're going to multiply both sides by 2 minus y. And that will cancel it out there. We'll multiply the left-hand side by 2 minus y as well. Be sure you put that in parentheses because you need to distribute. And so on the left-hand side, we'll have x multiplied by 2 minus y. And on the right-hand side, we'll just have 2y. And now we can distribute the x to both terms because now we have a y stuck in a parenthesis. Again, if we're trying to solve for y, we can't have that be the case. So when we distribute the x, we'll have 2x minus xy is equal to 2y. So now we have two different terms, I'm going to underline them in blue, where we have a y, but the y isn't stuck in a denominator or in a parenthesis or bracket or anything like that anymore. So now what we can do is we can write all of our y terms on one side of the equation, isolated, and then we're going to factor y out. So we're going to add xy to both sides, and that's going to cause all of our y terms to be on the right-hand side now. So we have 2x is equal to 2y plus xy. And now we're going to factor the y out on the right-hand side. So we'll have 2x is equal to, pull a y out of both of those terms, and we're left with 2 plus x. And now we have y multiplied by one term. So we've changed both of our y's, or the multiple number of y's, into just one by factoring. And in general, that's what the type of algebra you'd have to use for any problem like this. If you have multiple y's, you want to isolate them on one side and factor them out, and now you only have one. And the only thing separating us from having that y completely isolated is it's currently multiplied by 2 plus x, so we're going to divide both sides of this equation by 2 plus x. And so now we have the y isolated. So coming over here, let's rewrite what we have. We have y is equal to 2x over 2 plus x. And so now we've finished with step 3, so going on to step 4, we just want to replace our isolated y with the inverse function notation. So our original function was f of x, so the inverse notation would be f inverse, or f negative 1 of x, is equal to 2x over 2 plus x. And that is our inverse. Again, you could always verify this by plugging your inverse function into the original f function. If it simplifies to just equaling x, you're good. Then plug the original function into the inverse function, and again, use algebra and simplification. If it ends up being just an x, then you're definitely good. But as always, if you follow these steps carefully, you're certainly going to get the right answer. So there you are.